Hey, people. You don't know it's Mr. Surplus, addicted to geography right here. And I will be, for the next couple of minutes, explaining some concepts, you know, that I have discussed with my class. I left some questions for them. Unfortunately, I wasn't able to get to the class for that day. So we're having a rap session right now. And an old head like me is using up the technology. So hopefully I will be sending the link to my class so that they may come in, and they are already have they should have answers to the questions. So therefore we'll be discussing. It should be an interactive session. um, I'll see what they put in the comments, and I'll try to answer and clear up any misconceptions. So if you're new, welcome. Well, definitely you're new because this is a new channel. Yeah, but if you're new, welcome to Addicted to Geography, where we discuss geography-based content. Because we love geography over here. Um, yeah, a little backstory. I am a teacher of geography. I have been teaching geography for so many years now, and you know, this is uh, as I said, I'm trying to incorporate the technology as best as I can, because I'm a very old head. As you can see, a lot of gray hairs, but I I'm trying my best. So I will be sending the link to my students shortly. So if you see me disappear for a bit, that's me sending off the link. I just wanted to test it out to ensure that everything is on the up and up. Let's see what it looks like. Hopefully I don't get a negative feedback. It's weird, I'm seeing myself. Alright, so as I said, I'll be sending the link to my students so that they may log on. So oh, looks much better now. All right, so welcome. What does it stand for? Well, the ITCZ is an acronym that means Intertropical Convergence Zone. Intertropical Convergence Zone. All right, so while my students take their time out to log on, let me just put some information in this group. Now, the Intertropical Convergence Zone is a belt of low pressure which circles the Earth generally near the equator. And this is where the trade winds of the northern and southern hemisphere come together. And it's characterized by convective activity, which generates often some intense thunderstorms. It is most active over continental land masses by day and less active over the oceans. So, years ago, when um, steam engines and these newer boats and motors and such were not popular, the sailors or the traders, they used to move from country to country or place to place using sailboats. So, very important or very imperative was the use of wind to power these boats to get them from point A to point B and even to point C. So, some of these winds were seen as very optimal to carry these sailboats, and so they were coined or they were named trade winds. And as such, we now know them as trade winds, even though they are not as important for the conveyance of these boats. We still acknowledge that name, trade winds. Now, if we remember, a wind is named according to where it is coming from, not actually where it's going. So these winds, they are blowing from the northeast, and in the case of the southeast trade winds, it's blowing from the southeast, and as such, they are referred to as the northeast trade winds, or in the case of the southeast, the or help to facilitate trade. Now, if they also observed where the wind is most powerful, then they also make note of stuck in an area where there is no wind. That means there would be little motion. Yeah. Yeah, my students, yeah, probably is logging on right now and saying, yeah, motion. All right, so there will be little motion in that area, so therefore they will try to avoid that area or make a note of that area. So that in a particular area near the equator, there was an area of calm and little wind, or in other words, a low pressure area. In other words, a low pressure area. Now, this area was referred to back in the day as the doldrums, and that is actually where we are, where our story joins this one, because that area was where the east trade winds met with the southeast trade winds, and there was a collision that happened, and then a massive updraft. So the two winds collided, or came together, or converged, and then there was a massive updraft. So they were pushed upwards. Now, if the winds are pushed upwards, or they are being forced to rise, then another geographic phenomenon occurs, because winds which are forced to rise will eventually cool, because the higher you go, the colder it gets. If we remember that. So the higher you go, the colder it will get. So as these winds are forced to rise and they are moving upwards, then they are eventually going to be cooled. And most of these winds actually have some amount of moisture within them. Or so when they rise, they are forced to cool, and then condensation takes place, and this produces visible water droplets. Anybody knows what a collection of visible water droplets is? Yeah, that's right. Those are clouds. I feel like Dora a while ago. Yeah. Do you know what a visible collection of water droplets is? Yeah, I feel like Dora. Yeah, so that would be a cloud. So a cloud is created, and these are actually huge towering clouds that are created. They are cumulonimbus clouds that are created because of this convective activity, and they produce a lot of rain. So the intertropical convergence zone means that the winds converge within the tropics, or within an area that is near to the equator. Now, what is so significant about this equator? Anybody? Anybody? Just checking to see if anybody has. Alright, so the equator, aside from being the Earth's belt, or the one of the major lines that the Earth has, like for example, the major line of latitude is the equator, and the major line of longitude would be the prime meridian or the Greenwich meridian, depends on how you learned it. So the equator is actually the area where the sun's most concentrated rays focus on the majority of the year. Now, what do we mean by the sun's most concentrated rays? All right, let's go see that. Alright, so let's say that's our Earth, and the equator is roughly in the center. The equator is roughly in the center of the Earth. Now, over here, we have let's say we have the sun. Now, the most concentrated rays of the sun would fall in that region. Any other ray would actually be spread out, over a greater distance. See right here, small distance, great distance that would be spread out. So therefore, the angle that these rays hit cause lower intensity. Alright, and the concentrated rays concentrated rays would hit right about at the equator. Now, there are other things that would influence this. So, for example, our Earth is not bare as what my diagram would suggest. There would be actually layers of gases, or a blanket of gases, that surround our Earth, and we know this as our atmosphere. So the atmosphere would also play a part in diffusing or lowering the intensity of the heat in these areas. Now, that means, as you already guessed, that in these regions up here, because of the lower intensity of the heat, those regions will be colder than these regions. So we refer to these polar regions, and we have the temperate and these are the tropical regions. Tropical, and of course around the equator, yes, you guessed it, it would be the equatorial region. Now, tropical, because we know that this line is called the Tropic of Cancer, and this line is called the Tropic of Capricorn. Strange names. Yep, we'll discuss that in another video in the future. So, the sun's most concentrated rays would hit at or near the equator. That means that area would be the hottest. And as we know, areas around the equator, we know that that's a fact. That is one of the hottest areas on Earth. And as a result, when the two winds and the two air masses actually hit or converge in that area, that's why a lot of convective activity takes place. Now, why does the ITCZ appear to shift? That's the next question that I asked the class. Why does the ITCZ appear to shift? Well, simple reason is that during the year, the sun's most concentrated rays are not only stationary at the equator, but they appear to move upwards. And that's because our Earth has an axis. Anybody knows our Earth's axis? Our Earth's axis is tilted at 23.5 degrees. So our Earth's axis is actually tilted. So at some times of the year, the sun's most concentrated rays would actually be focused at the equator. But at another time of the year, the sun's most concentrated rays, that's another diagram. At another time of the year, the sun's most concentrated rays would actually drift upwards and would not be at the equator, but would actually be at the Tropic of Capricorn. So the sun would actually be focused on that area, and that's because of one, the Earth's tilt, and also the revolution of the Earth around the sun. Now the revolution and the tilt of the Earth's axis, those two are responsible for what we know as seasons. You know, the 4 times of the year when the temperature appears to change significantly. So for example, you have winter season, summer season, we have autumn, and we have spring. Now, the sun's most concentrated rays will be focused at the Tropic of Cancer here. But as the Earth moves around the sun, the tilt, which will not change, but it has moved around the sun. Therefore, our diagram will have to change a bit, and the sun now would actually be somewhere over here, because the Earth has revolved around the sun and is now on the other side, and because of this, the sun's most concentrated rays would move or shift downwards and be focused on the Tropic of Capricorn. Now notice in this diagram now, the southern hemisphere is now pointed towards the sun, and the northern hemisphere is now pointed away from the sun. Now, if something is pointed towards the sun, then it should be significantly hotter than something that's pointed away. Right? Yeah, I tell you, I feel like Dora when I ask these questions. And of course, if it's pointed away, and we are located, I'm in Jamaica right now, and we are located pretty much in the northern hemisphere. So when the sun is actually away, or the Earth is pointed away, I should say, from the sun, we experience the season which is known as winter. Yeah, I know some of you are saying, we really don't have winter because the temperature varies very little in the Caribbean. But nominally, we have a seasonal change, and we get winter around this time, around December 22 thereabouts. So if the so that will be the second part of our diagram, and that is the first part of our diagram where the sun's rays were here. Sun's rays were here at the Tropic of Capricorn, and then it moves around and it's now at the tropics of 1 and 2. So remember, it doesn't happen even though we have the diagram shows the sun shining on 2 areas. If you're just joining in, I'm not saying that the sun shines on 2 areas at the same time. We moved in sequence. So we started over here, and then the Earth revolved around the sun and would be on the other side of the sun now, and it would be focused there. So because the most concentrated rays shifts northwards to the Tropic of the Tropic of Cancer. It shifts northward to the Tropic of Cancer, then goes back southwards towards the equator, and then further southwards towards the Tropic of Capricorn. And the sun's most concentrated rays would cause a lot of heat and a lot of convection in that area. And the heat is what powers the convectional rainfall that happens in that area. So, because the sun's most concentrated rays moves upwards towards the north, comes back to the equator around the time of the year which we refer to as the equinoxes, and then moves southwards to around December 22, which is known as the winter solstice for the northern hemisphere. The ITCZ appears to follow this pattern, and that is why the ITCZ is not stationary. The ITCZ actually moves northwards and roughly stabilizes or stops around at the Tropic of Cancer, and then it moves southwards back to the equator. That's around the equinox. That's where you have spring or autumn. Those are the times of the years that we have the equinox. And then it moves. So around March, we will have a change of season. I think it's about next week. Yeah, we're in March right now. So we're gonna have a change of season. So the winter is gonna finally break up. This should be a relief for many persons way up north in Canada and some parts of the United States who are having very cold, a very cold winter which does not seem to want to end. So we're gonna have a break in the season, and we're gonna go to the equinox very soon, in the next 2 weeks. So the ITCZ would be moving towards the equator. It would be moving towards the equator at that time. As the year progresses, and we move from March, April, May, June, and so after 3 months, we would have another change in season. And as we know, in that time, we would have the summer solstice occurring, and the ITCZ would be moving downwards until we get back to December again, when the ITCZ would move all the way down to the Tropic of Capricorn. Alright? I hope I've cleared up a few things. I've not seen any questions, so if there were questions, then I would be able to better know what you're thinking. Alright. So I would have hoped for a little more people posting questions. I want to make another appeal so that I could answer other questions directly. Alright, so I'm going to be checking on my class to see what is happening. Bear with me 1 second. Alright, so I made an appeal to the students to drop their questions. So I'll be looking to see if there are any questions. Alright, so what I was trying to explain via the chalkboard is the apparent motion or shifting of the ITCZ throughout the year. Now, the position of the ITCZ varies with the seasons, and the seasons, as we know, are caused by the tilt of the Earth and the revolution around the Sun. So the ITCZ moves, but it doesn't move. It doesn't move. There is a lag time. There's a lag time behind the apparent movement of the sun's most concentrated rays. So it appears to lag by about a month or two, and this is actually referred to as the, well, it moves behind what is called the thermal equator. So it's not the actual position of the equator, but it is, as we know, the equator is where the sun's most concentrated rays are focused. So it appears to move to the places that are near to the equator that have the same. So you know that places at or around the equator will have that same heat factor because the sun's rays are focused within that area. Now, in July and August, over the Atlantic and the Pacific, the ITCZ is found between 5 and 15 degrees north of the equator. In Eastern Asia, the ITCZ may propagate up to 30 degrees north of the equator. In January, over the Atlantic, the ITCZ goes no further south than the equator, but it extends much further south in South America. Now, with respect to the Caribbean region, the ITCZ uh, has a great effect over our Caribbean neighbors in Guyana and also in Trinidad, and it brings an intense amount of rainfall in those territories. All right, just checking for questions. All right, big up, big up, big up to the guys from Port War. Yes, blessings. Yeah, man, we're talking about the Intertropical Convergence Zone. I left a few questions for my class. Unfortunately, I wasn't able to get to the class to discuss the answers. So they were supposed to research what is the ITCZ, and they were supposed to find out what is the relation or the correlation between the ITCZ and the sun's most concentrated rays, and also what is the relation between the Tropic of Cancer, Tropic of Capricorn, the equator, and the ITCZ. And why does it appear not stationary? Why does it appear to shift? You know. So we've been discussing that. Uh, but just like my regular classes, sometimes the students are there, but they are not talking. They are not participating. So what I mean. I don't know. I'm trying to see if they are actually um, present and just not conversing, or what is it? Or they probably didn't do the research, so therefore they won't be able to interact and ask me questions or provide me with answers. So I'm pretty much here doing, you know. Sometimes that's what teaching is. I guess they can watch the live stream later and pick up any information. So the ITTZ, yeah, you're going live at 5. All right, well, good. Let's see how that goes. So the intertropical convergence zone, it appears as a band of clouds, usually thunderstorms, that circle near the globe, and it extends for hundreds of miles. The ITCZ follows the sun in, in the position that varies seasonally, so it moves northern, as I said before, to the northern summer, and then south to the northern hemisphere's winter. And it brings, in the tropical regions, it brings a lot of, it makes a significant change in the wet and the dry seasons. It exists because of the convergence of the trade winds. So in the northern hemisphere, the trade winds move in a southwesterly direction, while in the southern hemisphere, they move in a northwesterly direction. And the point at which the trade winds meet, they converge, as I said before, and it forces the air upwards. So there's an updraft that happens. And that is basically what the ITCZ is. It's a convergence or a meeting of two air masses, the northeast trade winds and the southeast trade winds. And it appears to move because it follows the apparent motion of the sun's most concentrated rays throughout the year. As I said before, it brings a lot of thunderstorms and, convective, convectional type of rainfall. All right. In some regions, they refer to it as the tropical monsoon. And if we know anything about that word, we know that the monsoon it's a time of, it brings grief to some because it just rains and rains and rains and rains and rains and doesn't want to stop. And if the earth is not allowed to deal with that amount of rainfall, then it becomes quickly saturated, and you know what comes next: flooding. And the monsoon floods a lot of regions, causes a lot of grief. Alright, so I guess no one wants to. I see no more students. I see the guys from Portmore. I see Michelle Anderson Henry. I see surplus. But I don't see my students. Alright, well. This is this will be a testing experience. So I believe the next one will be much better. Alright, so as I said before, the thermal equator receives the most intense heat from the sun. Around June 20, the sun is overhead at Tropic of Cancer, aka 23.5 degrees north. And around December 20 to 22, it is around the Tropic of Capricorn, which is 23.5 degrees south. So the ITCZ, once again, I'm trying to drill it in. The ITCZ is not stationary. It moves northwards, then it drifts back southwards to the equator, then further south, but it doesn't go further than the Tropic of Capricorn, which is 23.5 degrees south. Now, there are actually two air masses. I said the northeast and the southeast trade winds. And we know that in Jamaica, the northeast trade winds moist, bring moist conditions towards the northern section or the northeast section of Jamaica. So the northeast trade winds, when they come across Jamaica, they meet upon the Blue Mountains, which are the highest mountain ranges in Jamaica, and they are forced to rise again, and they cause a different type of rainfall, which is called orographic rainfall or relief rainfall. As these northeast trade winds hit the Blue Mountains, they are forced to rise, they condense, and the water droplets form clouds and eventually rainfall. And the rainfall occurs at the highest regions of the Blue Mountains. So therefore, the parishes around will get rainfall. So that's one of the reasons Portland has a high amount of rainfall, probably the highest amount of rainfall in Jamaica. Rain appears to fall every day in Portland, or well, used to. And then the opposite of that is also true, that when it reaches the peak and it is no longer forced to rise, then it is going to descend. And if the higher you go, the colder it gets, and the more rain falls. If the higher you go, then the lower you go, or as you descend, the air gets warmer and it will get drier. And that is the reason places like Kingston, which are found on the other side of the Blue Mountains, those places are much drier and much, much, much warmer than the cool, cool, cool climes of Portland. So the northeast trade winds actually influence Jamaica, and the ITCZ or the ITCZ, as I said before, brings a lot of rainfall to territories such as the Guyana and Trinidad. And we know that Guyana has, they have rainforest conditions in their country. We have rainforest conditions in Jamaica, but not on the wide scale that Guyana has. All right, so I'm gonna be wrapping up in a few. Yeah, definitely, Mr. Cox. Definitely, Guyana has a huge rainforest. All right, just. All right, so in summary, ITTZ, Intertropical Convergence Zone, two air masses meeting up. The air masses, as we said before, are the northeast trade winds and the southeast trade winds. When they converge in the tropical region, that's why we get the ITCZ. When they converge, they are forced upwards, and there is an updraft, and then it produces condensation clouds, cumulonimbus clouds, a lot of rainfall. And because there is an updraft, all that air appears to go upwards, then there's a low pressure system that is left below that area. And we know that according to pressure, well, I hope you know that according to the pressure, air moves from high pressure into low pressure areas. So as the air masses go upwards, there's a low pressure area that is left around the equator, and previously it used to be referred to as the doldrums. So it's a low pressure, an area of calm, an area, you know, well, it's kind of like a vacuum. But there's another saying that nature never likes a vacuum. Nature abhors a vacuum. And therefore, if there's a vacuum created in nature, nature will find something to fill it. And yeah. Normally, when I say that in my classes, I get a big why. Why, sir? Why? And it's not even the good why, not even the WH why. They're not even asking why nature doesn't like that. They're telling me why because I said feel it and those sort of things. But anyways, so it's a low pressure. It's a low pressure area, and it brings a lot of convectional rainfall. It brings a lot of rainfall to these areas, and you know. So it's a good, yeah. This was a good attempt, I believe, at testing out um, the capabilities of this live thing. I don't often go live. Next time, I will prepare my students a little better. I don't know where they are. They're probably going to beach and enjoying themselves on this midterm break. And so next time we'll see. There should be more interactions because I want them to ask me questions. I want them to ask them so I can see where their mind is at. What is it that is giving them problems? But I guess I have brilliant students that don't have any problems. So everything is cemented and copacetic in their brain. So, you know, look out for more from this channel. Look out for more from it. We'll be posting more geography content because we love geography over here. I mean, geography is life. Some people say biology is life. No, but geography is life. Yeah, most awesome subject ever. Alright, so thanks again for tuning in. Bless up to the guys from Portmore. Bless up to Dave Cox, and of course, bless up to Michelle Anderson Henry all the time. So, yeah, man, definitely, Mr. Cox. Definitely next time, you know, I will have, you know, I'll be, I'll be more technologically savvy. I'll just press a button and something appears up on the screen and you can follow me. You know. So right now I tried using my laptop originally, but it was lagging behind like the ITC said. So I had to switch over to this device that I'm using here. I don't think it went bad. So, all right, so blessings and keep it geographical. You know what I mean? Stay addicted.